Okay. All right. So anyway, so let's do this. We were going to, let's try 20 steps. And let's see what happens. Well, that was a shame. So some of those aborted. Well, we might as well just do this, see what happens. Okay, so that one is still developing. Let's look at that first one. I think that first one is kind of interesting. Now, do we have any way, we don't have any monitoring from the external code, right?
What do you mean?
Well, I mean, we can't tell what's going on. I mean, I could just run it without a time constraint, but I can't interrupt it because my silly interrupts are broken in this version. Right? So let's run it for like 20 seconds. And
oh yeah, there is no internal monitoring of progress from C code. That's, yeah.
Okay, well, let's look at this rule, and then we can also look at the rule. Okay, so there it is.
Actually, that's
Oops.
a good idea. Let me add it to the list.
How would you do that? With some callback function or what?
Yeah, C++ code can call back current. Well, I mean, I don't know exactly how it will work, but
Okay, well, so then we probably want an option here called progress monitor or something.
well, definitely.
So this claimed to be 20 seconds. I don't know how long 20 seconds is. Sploff. Oh well, we didn't manage to make it 20 steps. Do you think we can make it to 15 steps? How many steps did we do up here? Only 8. So let's try 15 steps at 20 seconds. And then let's take a look at what that rule actually is. Oh, by the way, the other thing we can look at for some of these is, oh, there we go. Okay. So percent -1. That doesn't look that exciting, but who knows?
Can you do spring electrical embedding, right?
Yeah. Arguably, we should default to that in the output when we do a graph. Yeah, well, that's kind of fun. When we do graph list here, we probably should default to spring electrical embedding. Do you agree?
Yeah, and we should also make them consistent with each other, which would require us defaulting to it.
Fine. So let's make a note of that. Are you going to remember that, or should we put that on a list here? States.
Well, it's unavoidable.
Okay.
I mean, if we make them consistent, they have to have the same embedding.
No, I understand that. Okay. Hold on. With in the case of the graph is taken the same, let's not commit to what it is, for each graph in the list. Okay, now for example, this one, well, let's take a look at what the actual rule is here. If we can get a reasonable representation of it. Weird. What's that thing? See that left-hand side? There's a second self loop.
Disconnected.
It's disconnected, yes.
Interesting. Okay, so we were running the symbolic version of the code the whole time.
So note, this rule has a disconnected LHS. So even though it's a disconnected LHS, it reconnects itself, right? Because this is connected graph.
Yeah. I mean, it picks up, it picks up any piece that might be disconnected and connects it, which is what the rule says.
Right. That's very weird. You know, I'd always assumed that once a piece broke off, it was gone.
Well, yeah, except for this case.
Well, except for the fact that you can have rules in this model. You can have rules that you know automatically garbage collect pieces of the universe, so to speak. Except they don't garbage collect them.
But that is very
they
weird
recycle them.
It's non-local.
What's that?
Yeah. I mean, the weird thing about it is that it's not local.
Yeah. Okay. Fair enough.
Which is part of the reason why I didn't bother implementing it in C++ code.
Yeah. Okay. Because it can pick up pieces from anywhere. All right, that's very weird. Okay, so let's go back. Were there any others from this collection that we thought looked interesting? And I mean, okay, so we've still got one guy up here that we really don't know what the heck's going on with it. Okay, so that's currently our winner for the simplest one where we don't know what the heck's going on. But let's try looking, you know, even among, okay, hold on. Okay, so let's do this. I think what we should do, okay, so simpler random rules. So let's get the random rules here. Okay, so what right now we've got 6 there. So let's go down to, I think we'd enumerated up to 4, if I remember correctly. But I'm not sure if I'd enumerated up to, so let's take a look at the 4s. Okay, and then for the 4s, what we want to do here is, I think we might as well just run the graph thing. So let's write the code. Just say if hash not equal to $aborted, then graph rule at hash, otherwise just hash. We'll just put aborted in there. Apply that to the time constraint of this. Okay, so that's an 8-step thing. And so let's go ahead and generate this, and then let's go ahead and do this. Oh, we forgot something here. We need to say -1 there. Or should we shouldn't even bother with that. We should just do hash, and we should just here, we should say final state, right?
Yeah.
Okay, boring. Now, probably what we should do here is we can do a thing where we make buttons and we just have to click them to get, okay, so we can do another run of this. We can just do that because it's not going to matter if they're all boring. Who cares? I don't think that one is completely boring. So let's do %58 sub 2. That's that rule. And then what we want to do here That's the time constrained. Oops. You know what? I might as well just take the whole thing there. We might as well just, you know what? Let's just define something where we say safe, always a bad word. Safe model test. And then we want to just give the rule and steps and max time, which will default to 4 seconds. And that will be this thing here, max time.
What about init?
I'm not bothering with that because I'm generating the init automatically here.
All right, okay.
Okay. Safe model test of this guy. I mean, I don't think it's necessarily correct to just do the self loops. Let's do 10. Did that just die out? Let's try 14. Oh, that's boring. It's kind of amusing. I mean, it's basically just writing more. It's just 2 loops, which is probably, yeah, it's boring. 2 of its loops just extend. All right, let's try this again. Maybe we should go for these ones a little bit further. Let's go 10 steps here, see what we can do with that. Oh, in fact, you know what? Let's not use any of this stuff. Let's just say in here, instead of all of that, we just want to say safe model test of hash 10 4. And then we want to do that for this. Nothing too exciting there. All right, let's try doing a slightly bigger one. Let's try 30 of them. We could make these tiny just for don't think there's anything there. Okay, so let's try moving up. So that was 4. Okay, so this is the case of LHS 3 edges. Well, basically this is 3 edges goes to 4 edges. 3 edges, 3 symbols goes to 4 edges, 4 symbols. Right, that's that case. So now the next case that we might want to do, I think, is 5 edges on the right. Now, each of these we also should eventually enumerate exhaustively, but for the time being, and then what we'll need is some tests. Okay, so this is 5 edges on the right-hand side. Okay. Well, I think there's already some interesting stuff here. I reckon that one is kind of interesting. And of course, we've been really stupid here not labeling the output. So actually, let's just put a label in the output here. Is there a map monitored indexed here?
No.
Is there a parallel table monitored?
No, there's only one.
Okay. Well, then we have to put, oh, splarf. I mean, then you know, the issue is how do we get the how do we get these? Can we do a pop-up menu or something, a pop-up window, and then just copy out of the pop-up? Does that work? Pop-up window. All right, let's try. It might be crazy. Pop-up. Well, actually, why don't we try on a simpler thing? Pop-up window of this, comma, hello. Okay, click
Is
it.
it possible to make it a button that will copy the rule?
Yes, that's what I was, that was the other strategy. That's what I was doing above. The problem with that is you then have to, that we're making a list of all of them, which is not what I mean, we can absolutely do
No,
that. But
then it should just copy it so you can paste it somewhere else.
Oh, I see what you're saying. I think there is, yeah, I think it's called the paste button, isn't it?
Well, that pastes
No,
it,
that's
but
a
we just
paste,
need to
but
copy it.
yeah, so I think button, okay, so let's see, is there a copy to clipboard? All right, we can try that, I guess. So that would then be, and I kind of like the idea of being able to pop up the rule, but all right, so then that would be something like button of this, copy to clipboard, 678, boom, paste. There we go. Okay. Button, copy to clipboard. Now, presumably we could just return, you know what, let's do this. Let's make safe model test, wherever it was. Arguably, we should put this in SWinit. Let's do that. That random enumeration is pretty stupid. Okay, and then we've got safe model test button would be rule steps max time, and then that would be button of safe model test of rule. I mean, I'm a little bit concerned that when we have a button, we won't be able to like expand it or anything like that. But anyway, let's not worry about that for right now. Save model test rule, whereas that click thing that I was talking about will let you do that. Copy to clipboard of rule. What am I doing? all steps max time, and that's the button, right? Safe model test button. So here we want to say safe model test button of those things. And in order to not lose all that stuff, that was on line 68. Okay. All right. So we got this guy. I mean, I'm not sure how efficient this is. I kind of prefer the thing where you, okay, let's do that guy. And then we've got safe model test of that thing, comma, let's say 20, comma 5, 10 seconds. Let's give it 10 seconds. Great. That thing is just a tangled version of a circle. Okay. That thing, let's say 20, comma 10. Okay, that's a little bit more exciting. What is that? Okay, let's go. Let's try and go 40 steps. Was that a transient? And then it's just going to be a little sort of rising sun or something? What the heck is that? Is that maybe this thing is just
the left-hand side is still interesting.
No, but look, I don't think the left-hand side has changed. Do you see any evidence the left-hand side's changed?
Good point.
I think it's just being dragged along. I think it's got a, you know, it's the sun is dragging along a chariot. What's that?
Where did it come from then?
Where did what come from?
The left-hand side.
Well, I don't know what here, let's just try a little bit longer. Let's just try 200 steps, see if we can make it there. Yeah, look, that left-hand side is just being dragged along by the thing on the right. However, I think the causal graph of this thing might be kind of interesting. What do you think? I think the causal graph is going to show something on...
I'm also curious to try different initial conditions.
Yeah, well, I think it's going to, okay, fine. Let's say causal graph here, and let's say 50 steps or something, causal graph. Oh, and we have to give the initial condition, which is table 003, right? I think, does it have to be in a sublist? I don't think it does. Okay, that is a very long in the tooth.
Well, that's not surprising. So it starts interesting and then it degenerates.
Yeah. All right, so let's try this thing. Well, let's just try this.
Maybe we could just try adding extra 0, 0, for example.
Sure. Well, do you want to try the final state? Let's try the final state. I mean, this may blow up. No, it's a little bit, it's got more juice on the left. So, I mean, this is presumably computing something. You know, who knows what it's computing? It's computing. Now, I don't know what happens. Let's try going down to...
Well, what's interesting about it is that there are no matches anymore on the left-hand side.
I understand. It died out. And it only matches on the right. So it's like a busy beaver that goes a certain time and then stops. Oh my gosh. That's crazy.
Well, it is very interesting, actually. it's kind of, well, these things are kind of like particles, and I mean,
Maybe.
in a
Well,
sense.
let's look at their causal graph in a minute. Let's try 8. Okay, let's try like 80 steps at 8. So at 8, it's getting less interesting again, I would
Well,
say.
the question is if it can degenerate into something else.
What do you mean? The whole thing?
Well, now it produces this stuff at the edges. Can it produce something else?
I understand. If we give it some different initial condition, well, let's try that. But
Yeah.
okay, but so first of all, let's get the causal graph.
Well, it
Background
probably will
noise,
just have
background noise.
three branches in. Yeah.
Well, okay, so that causal graph, yeah, basically it's got 3 disconnected pieces.
Right.
Okay, so a question would be, if instead of doing this, we have a 0, 1, 0, 1, let's imagine we come back here and we try
0, 1, 0, 1 won't work because it has 3, 2, 2, 3
I see.
in the input.
So what do you recommend?
Well, because copy the input.
That's really a lame thing for a system to do. See?
Okay.
Totally lame. It doesn't care. When it has a copy of its input, it's just boring. All right, so let's modify the input. Let's put a 2, 2 there. Also boring.
That didn't do anything. It didn't match. We
Okay,
need
so
2, 2, 2, 2.
What?
No, we need 2, 2, 2, 2 because it would match 3, 2 to 3 otherwise.
But it doesn't care what these symbols are.
No, it has 3, 2 to 3, meaning that it should have loop that goes back in between 2 edges to match anything.
Yeah, but we've got that. 2, 2, 1, 1. Oh, no, I
We
see.
don't.
I see. So, okay, so if we have 2, 2 here.
So it's a 2-vertex loop connected to something else as well. That's what
Okay,
it is.
so there is our sunburst thingy. That must be the origin of that. It's a single symbol. So what it's doing is it's okay. So I have a claim about what's going to happen here. So my claim is let's give it another. Let's give it just a 0, 0 there. Oh, that's just disconnected.
Well, that's disconnected, yeah.
Okay, so if we give it a 3, 3 here. Okay. Now what happens if we give it another? If we give it another 3, 3. What's that doing? Okay, let's give it just a whole bunch more 3, 3s. Although I want to give it a 3, 4 there, just for the hell of it. Is that going to make any difference, or is that just not going to match? Can you see? That does less.
Huh.
I don't really understand why that does less. Do you understand that? I would have expected.
Well, it matched something on the second step, probably, that generated it. I mean, I don't see why it cannot happen in general. I don't understand this specific case.
But this is an updating order issue, because there must be an updating order where it could have escaped and done more.
Oh, definitely. So it's not confluent.
Yeah. But we don't yet know. Hopefully Jonathan is going to deliver a list of small confluent ones. He has the technology to find that, doesn't he? Or at least he claims he does.
He says that. I never seen it myself.
Well, and also his scheme requires, you go a certain number of steps to check confluence. Okay,
Well,
let's
might be inevitable.
what?
That might be inevitable.
No, I know confluence is undecidable, so you're never going to be able to get to.
Right.
Okay, so look, what we're finding here is that there is some somewhat non-trivial behavior. Let's try this again. Let's try another 5-edge, right? This is 35-edged things. Let's see whether there's anything else we see here. And then we'll try 6 edges and so on. Okay, so I think we've seen ones like that before. One thing that's odd is that there's nothing here that sort of seems like it's becoming a manifold. Whereas we definitely have that with bigger ones. I feel like just doing this. I mean, there may be a minimum size at which that can happen. See whether some of these will work. Okay, so that's that guy again. I think this one is not developing in an interesting way. I mean, that one seems to be possibly interesting. Maybe what we should do is to show them at 2 successive steps here and just see whether they have much activity between those steps. Okay, let's do this. I have so many notebooks full of explorations like this for different kinds of systems. It's kind of going back to like the beginning of the 1990s. Okay, that's kind of fun. Let's try going a bit further. Well, fun though it may be, it's died out. Oh, but what the heck is that doing? Table, 8 there. Let's try doing that for just 3. Okay. Aha, there is still some activity. And now it's died out. So this one, at least for these initial conditions. So its causal network, what do you think it's going to look like? It's going to be a finite causal network, presumably. I wish this.
Well, it looks like it's confluent, isn't it? Well, actually, yeah. No, it has nothing to do with that. They need to have multi-way system.
Right. It's a pity. We need our causal graphs to look different from our other graphs. This is way too confusing. We should at least use dashed lines or something here or something to indicate so that we know that that's a different kind of graph. All right, let's try doing some hypergraphs. I mean, we could also try double rules, two rules. What do you think? Let's try 2 rules. I think that might be interesting. Well, although there's already interesting stuff, clearly there's non-trivial stuff, even with one rule. Does it surprise us that there's interesting stuff with one rule?
Not really. I mean, we've seen it before.
No, we haven't. In most systems with one rule, you just get either growth or non-growth, right? I mean, I think in all of these, okay, so
Well,
I claim,
it is either growth. I mean, it has to be growth, so the rule is applied because output is larger than input.
sure, which means it's more interesting to have rules where the input and output, where it can go both ways.
Yeah. Actually, I think for now we should try hypergraphs first because of the updating order. It will just ignore the second rule too much.
Fair enough. Are you going to be able to fix that? Okay, so that's another thing in the to-do list, right?
Yeah.
Hold on. That's an important thing in the to-do list, I would say. Okay,
Well,
that's
there are a
here.
lot of important.
Okay. Fix updating order.
Well, I mean, this I know for a long time. I even have issue on GitHub for that.
Okay. Fix updating orders for multiple rules. So do you know how to do it?
In C++ code, it's easy to do.
Fine.
In
We'll just,
Wolfram language code, it's harder, but I'm sure there's some way.
well, okay, but you should do it in the C++ code so we can at least try it for a bunch of cases. And you should just have it generate a warning message if it has to run the symbolic code.
Yeah, I agree. But it wouldn't be default then.
Why not? I mean, it's running.
Because default in Wolfram language code shouldn't generate a warning.
No, wait a minute. Generate a warning if the rule has to run uncompiled, right? That's all I'm saying. So in other words, if you don't have, if the rule has to run
The other
uncompiled,
round, it's C++ code, it's easy to do.
I
In
understand that.
Wolfram
I
language code,
understand.
it's harder to
So
do.
I'm saying generate a warning if the rule has to run uncompiled and will have bad multi-rule updating order. See what I'm saying? So in other words, the warning should just say,
No, I don't think it should return the result with the wrong order. It should just return this order is not supported and not evaluate.
all right, okay, either way.
And then the default should be such that it works in both versions. Otherwise, the symbolic version would never evaluate by default.
I don't understand what you're saying. I don't understand. In the case, look, here's the flow. Okay, if there's a single rule, we already know what to do, right?
Yeah.
Okay, let's say there are multiple rules. Then what I think it should do is, if there are multiple rules and it is a case that the compiled code can handle, it should just use the compiled code. If it's multiple rules and the compiled code cannot handle it, then it should fall back to the symbolic code, issuing a message saying that it is doing that and that therefore the updating order will be screwy.
I don't think it should return the result if the updating order is not the one specified.
But there isn't anything specified. It's a default updating order. The updating order is automatic.
Yeah, but default updating order is something specific. I don't think it should be
All right,
automatic
fine.
it's not defined.
Fine. Okay.
I mean, we could just have a symbolic version fail by default for multiple rules, which probably wouldn't be that bad.
Okay. All right. Return unevaluated if the rule has to run uncompiled and will have bad multi-rule updating order. Okay, fine. All right. Should we go on and try some okay, so what we've done is 3 edges, 3 symbols goes to 5 edges, right? Okay,
Yeah.
so what we could do now is we can look at something with a hyperedge. Okay, so here, let me just save this away.
Actually, single rule updating order that we decided on recently is also different from the one used now.
Which single rule updating order?
So right now we take the one which has the largest index smallest, but right now it takes the one that has the first index smallest.
Look, whatever it's doing now, I mean, look, what we need is a collection of different updating order conventions, and we need to be able to try each rule with multiple ones.
Yeah.
That's the only way this is going to work. But I mean, it doesn't. What are you saying? I mean, that we've documented the thing that isn't what it's doing?
Well, yeah, it's not what it's doing now, but it is what it should do.
Well, but look, we don't need to change the default. We just need to put in the new updating order, and then
Yeah,
we
I
should
think
try
that's
a
the
bunch of.
first thing I should do, to implement some of them in some implementations and make this option without changing the default.
Yes, I agree completely. If we change the default,
Okay.
then every single thing we've done will be wrong, which seems like a bad idea right
I mean,
now.
we do need to change default at some point because current default doesn't make sense.
Whatever. I mean, you need to explain to me these defaults, but let's not do that right now. I mean, let's wait until we can actually see these things running and actually generate. I mean, if you have a chance to generate a notebook that shows more explicitly what these updating orders look like. So in other words, explicitly show, given the actual sets,
Well,
which
that
thing it
would,
is pitting
yeah,
on.
I will have to do it before merging anyway, because it will be PR message.
Okay, fine. However you want to do this. Okay, all right. Let's all right. So then let's try here. Okay, so we've got 3 edges with 3 symbols to 5 edges with 4 symbols. So let's try, what do you want to do? You want to say on the left-hand side, should we have a hyperedge? What do you think?
Well, it should on both sides.
I know, but how many hyperedges? Okay, what should we try? We could try
We could
2
all
edges. What's that?
I mean, we could make all of them hyperedges.
All right.
That would be
3, okay, so 3 edges, ternary edges. Let's say, should we have 2 ternary edges? Let's start off with 2 ternary edges with, let's say, 2 symbols. Okay, so hyperedge based rules. Okay, 2 symbols. Let's go to 3 ternary edges with 3 symbols. Okay, so that to get a ternary edge, we just do this with 2 symbols. And here we have 3 symbols. And we're going to get 3. Look, I bet there aren't very many of these. How many do you think there are of these? I bet if we just do a union of that, we'll get fewer. We didn't. Okay. All right. So that's a few of those. Okay. So now we get to do our oh shoot. We don't get to do the same thing because this is that's based on just using graph of rules. So this has got to be the actual
yeah, we'll have to use ordered hypergraph plot.
Right. This is getting hacky, but we'll do it anyway. Safe hypermodel test. safe. Okay, so here.
I mean, if it's really too slow, we can always fall back to colors, which is better than nothing.
Yeah, I understand. Well, this better not be too slow. I mean, we need to make sure it works at decent speed. What is the initial state? Well, in this case, we need to do, let's take the same shape as the initial condition, but all self loops. Okay?
Yeah, makes sense.
So let's say,
well, just first of rule with all integers replace to zeros.
Exactly what I was going to do. Total hack. I don't even know that.
Well, for anonymous rules, it should work in all cases.
Right. Okay. Save hypermodel test button. Okay. Hash 10, 4 seconds. And then let's say parallel map monitored. Map that over %106. Boring. Okay. All right, let's try. What do you think?
Wait, we need larger output than input in the rules, otherwise it will always be boring.
We have larger output than input.
Do we?
Oh no,
I
we
think
don't.
we have 3.
We don't. We meant to do here 3, 2. No, 2, 3. Okay. That's quite jolly. Nothing very exciting, but quite jolly. I just want to check that the copy works. Yes, it does. Let's just check it works down here. Yep. Okay. Then we can go ahead and just do it. So here, let's try it again. Nothing too exciting. All right, let's go up to a bigger size. Okay, so this is 2 edges. 2, 3 edges goes to 3. We're not doing mixed here. We could do some mixed ones. Okay, so let's do, what should we do here? Let's increase the right-hand side. Okay, to 4 those.
Do you think we should increase the number of vertices?
For the initial condition?
No, for the rule. I mean, the number of symbols.
I don't think so. What's this? Let's look at that guy. Oh God, we gotta do its. So here we've got table 000, comma 3, 10. Ordered hypergraph plot. What is that thing? I think that thing is not going to do anything. I think it's now dead. But I'm wrong. All right. And can we see if this thing, okay, let's go to 25, let's see what it's doing. Okay, that's somewhat lively. Okay, so let's take a look at what that actual rule is. So I don't understand that. There's presumably some edges missing here, because that doesn't look like a ternary edge
they're missing.
story.
I think the self loops are missing.
Okay, yeah, the 222 self loop is missing. All right, so we have to get those. Okay, but anyway, let's take a look at this thing. What do you think the causal graph is going to look like for this guy? I think it's going to be very regular. Oh my gosh. Oh, it didn't go. It's not layered. Oh, well, that's kind of interesting, isn't it? Maybe it isn't interesting. I'm not sure. Let's see. Let's try and go to 100-step causal graph. All right, what is that? That's not a hyperbolic object, is it? It's not. Or is it? Yeah, it is. That has limited communication, I would say. See what it looks like at
What happens is that it's a path graph, but like in a spiral, there are connections between layers.
Oh dear.
It looks like a causal network for something that travels along the network.
Travels what?
Travels along the network. So it travels, which creates a path part of the causal graph. But then because it travels to different places, it has this long-range connections on this path.
I don't see a lot of long-range connections. Where are the long-range connections here?
So, I don't know how to show you. Okay, can you look at the layer case?
You can annotate. You can annotate on the screen. Just go to the annotate thing.
Let's see.
You can draw on the screen. What's that?
Okay, so you see this goes in this direction.
I'm not seeing anything.
And then it goes.
I'm not seeing anything. If you're annotating, I'm not seeing. Oh, there we go. Okay.
Okay, it's not real time. Okay.
Oh, I see what you're saying. Oops.
Okay, what should I do with it now? Okay.
I think there's a clear button. Okay, so this is a somewhat non-trivial object. Okay, so let's understand what that one is. So that one is a 2 to 4, 3 to 3. All right, so that motivates me to try another one of these. Yeah, that one is a nice non-trivial object, I think. Okay. Let's just do 50 of them just for the hell of it. You never know what you're going to find. This is where we need more CPUs. I mean, I've only got 12 here. I mean, I could run, even at my house, I have another probably 50 CPUs on various random machines. Hey, Sushma, are you still with us?
Yes.
Hi there.
Hi.
It would be nice to see if Roger can, you know, if we can get this running with, you know, so that I'm able to use remote kernels on these other machines. That would be great.
Okay.
I mean, I don't know what's involved in doing that. I would hope that there's just some top-level remote evaluate thing. This is a bad sign. What happened here? Why is this stuck? Why is it stuck at 5 out of 50? I mean, how could
Well, it
parallel
seems
map?
like a lot of rules are too slow.
Well, but we gave it a 4-second timeout. At 4 times 50 is a while, but
Well,
still it should be in
is
parallel.
strange.
What's that?
Yeah, that is strange that timeout doesn't work.
Oh, for goodness sake, look at this thing again. That's the exact same bug we had before with the parallel kernel status.
Let me take a screenshot.
Yeah.
Okay, done.
Well, any bright ideas here other than just killing everything? Why would the parallel map, what is the monitor of the parallel map picking up on? What does it mean, 5 out of 50?
It means 5 of them finished evaluating.
Okay. Oh, I see. Completely finished, like whatever CPUs they were on.
Yeah, if I remember right, that's what it is.
All right, let me look here. Why am I not seeing like a boatload? I see a boatload of things here.
Wait, they're not doing anything. I mean, if you sort it by CPU times, they should be at the top. But
Well, some
somehow
of
it's
them
running
are.
it all the same kernel, which is strange.
Well, maybe the other kernel's finished, and that one is just having a hard time. And because we don't have,
only 5 of them finished.
well, this looks like a bad piece of load balancing.
I think it should do that.
What's that?
Especially given, I don't think it should do that. Especially given that it should have a board in it.
Well, actually, look at this. The fraction of the CPU is not long. Wait a second. That is it possible the master kernel is that one there is the master kernel?
Well, it's possible.
Because look, these other ones are actually taking pieces of the CPU. But why would the master kernel, maybe it's returning something here to the master kernel and it's croaking. Possibly because one of them is too big. All right, do you see any alternative? Do we have any mechanism for killing this other than, do you have any mechanism to send an interrupt other than,
Well, I don't know any other mechanism except for aborting it.
one possibility would be to start another Wolfram engine and try to send this a SIGINT. Send the process a SIGINT. Yeah, why don't we send this process a SIGINT? Any reason not to do that? If we can get its process ID, we just send it a SIGINT.
Oh, we could just kill the parallel kernel instead of the master kernel.
Well, if we can figure out what that one is, but okay, so all right, let's
Well,
use
there is one
technology.
that's clearly broken, so
Okay, hold on. Let's use some technology here. I also don't understand why the CPU load isn't higher, because I'm looking at the total CPU. Oh, I see. The CPU load is because I have 12 processors.
it's an average.
Yeah. Okay. So process, what is it? Is that process status? Is that the right thing? Gives the current state of the external process located by the process, by that process object. Come on.
What do you want to do with it?
Watch, it's going to work beautifully. Why isn't that referenced? Why isn't processes referenced? No, that's not the right thing. What I want is, oh, system processes. That's the right thing. System process data. Okay. So what do you conclude from this?
I think we need to see the hierarchy. Actually, if we go back to activity monitor, there is a way to display it as a hierarchy.
Well, we can see the hierarchy here. The PPIDs for those. Look, there's the PPID for those. There's 12 things launched from 11.441.
Okay, which one uses CPU right now?
Well, this one, 11.450. Okay.
Well, that's the total time. We need to know the current time.
Well, it looks like that guy. No, that looks
How do
like
we
it's.
know? That's a system versus user time. It's not. It's not now in the past.
What?
What we need is present load, not total time, but like time within the last second.
Well, I would like to try killing. Which process do you think is the most likely to be misbehaving?
Well, can
Okay,
you check it in the activity monitor?
Yeah, what would you like me to check?
Just sort by CPU time and take the first one.
Percentage CPU or CPU
Yeah,
time?
no, percentage CPU.
Okay, but I also have to sort by process name. So that guy there,
Yeah, so it's
PPID 11450.
Yeah, so that's a parallel one.
Yeah.
So you can probably just kill it from the activity monitor. I should probably do force quit.
Okay. Kaboom.
Okay, now it's stuck at 12. Yeah, for some reason it runs only one kernel. That is strange.
Oh, but look, what's happening is it's redoing the queue. It's requeuing. So we just released that kernel, but another one just went under the bus, so to speak. right? It
Oh,
requeued the
yeah.
evaluation.
Yeah.
By the way, Sushma, if you want to take a screenshot of this, this is hardly beautiful. What
Okay.
happened here,
Mm-hmm.
particularly with that sub context being shown up there. Okay, and then we got another CPU, another.
Well, if we do it a bunch of time, maybe it will work. I'm not sure about it.
11449. Okay, I'll kill 11449. We've got another one that's at the top of the CPU thing. Okay. Okay, now it's requeuing. Oh, for goodness sake, look at that. It just jumped.
No, actually, the counter wouldn't work in this case. It would go over 50 because it doesn't take into account that it's requeuing something.
Okay, I think this is hopeless. I think this is not going to work. I mean, this is an example of what we have to do, you know, when we move this out to running in large scale parallel. You know, what we should probably be doing here is to run this asynchronously with each one running asynchronously, right? And just reporting back. And then we should collect the results. Because in the end, well, we also should have better protections inside the, presumably inside the low-level compiled code against this kind of thing happening. Because I don't know where that failure is occurring.
I'm wondering, is it possible to have a system level abort? So it doesn't have to be implemented by the user.
What do you mean? I mean, we've got that with time constrained.
Yeah, but
Is
it
it-
requires something that I need to do in C++ code. I'm wondering if it's possible to do on Wolfram kernel side. So
To do
to
what?
abort anything.
Yes, you say kill process, and if you've got the PID, you can do it.
But it's not a process, it's a library, which
I
is in
don't
the
know.
same process.
Yeah, I understand. I understand.
I mean, it
I
might
do
not be
not know.
possible. I don't know.
I
but
don't know enough about LibraryLink to know if there's a kill mechanism there. You should ask somebody who knows LibraryLink.
Well,
All right,
there is now.
there is
But
not.
if it is possible to make, it will be better than implementing it, than requiring users to implement it.
No, I understand. The question is whether it can clean up after itself.
Yeah.
Can it? Is it
I don't
sandboxed enough to clean up after itself?
I don't know.
I think that's what you lose from having the thing library linked in. This is a pretty picture. Maybe we should tweet it out. Just in the category of just utterly obscure, you know.
We should at least
Tweet out
tweet
that
the code
line,
as
that
well.
whole. What's that?
We should at least tweet the code as well.
Yeah, right, exactly. Which just makes it completely obscure. But,
no, I mean, if you link to the GitHub repository,
oh yeah,
read the code
but
and the output.
then it's too complicated. It's just a
Very much more interesting.
yes, but let's first of all explain what we're doing before we worry about that. Okay. All right, so this is dead. So let's go ahead. We should probably wrap up fairly soon, but let's just do one more try here, since we did find something interesting even in the very first run of, so hopefully this will kill off, yeah, hopefully all the parallel kernels die happily. I think they will. I don't think that's broken. Now, what do you think we should do here? Do you think we should just, I mean, I don't see how we can do anything other than just retry this. Let's try it. It's just a little bit of voodoo. Let's make that 30 there. I don't see anything better than just retry this. Unless we want to, oh, should we echo it before we, should we echo the rule before we actually run it?
Maybe.
I don't know whether that's going to make any difference because it's in parallel anyway. Does it even work? Does echo even work for parallel stuff?
I think it does.
Oh, that's cool. Oh, then we know which kernel number is at fault if something goes wrong. There's a lot of these pinwheely things. Okay, so that was easy.
Well, there are a lot of them in general.
Yeah. Okay, so that was, again, that was a 2 goes to 4. 2 with 2 symbols goes to 4. Okay, well, it seems like doing 30 is somehow oops. Oh, I didn't do the monitoring thing here that I did up here. That's a weird one with some disconnected stuff. Nothing too exciting. Should we try? We could try increasing the number of symbols. Look, we know we got something interesting before, so we can try again here. We also could try different initial conditions. Oh, we've forgotten to echo them again. I wonder whether that's going to turn into anything. Let's just have a little look at that guy. I don't think these are going to turn into anything. I think they're just going to be stringy things that keep going longer. I think it's dead. Like a parrot. Okay, doesn't make it. All right, well, we did find one interesting one in this category. So let's keep looking at a couple more times. And then we could just try running. Do you think we should try running mix?
Yeah.
Okay, let's try doing a mixed one. Might as well delete these.
Should probably try it with more vertices as well.
More vertices on the right or the left?
Well, both.
All right, let's try more vertices and then we'll try mixed. Okay, so far we have one interesting one here. I like that one. That one is really pretty cool. Okay, should we go to 3? Let's go to 4 here. Okay. Wait a minute, we'd already done that. Did we get confused here? Let's see. This one is a 4. That one is a 4. Oh, we already had done that.
Is it 4 edges or 4 symbols?
4 edges.
Yeah, but I was talking about 4 symbols.
Okay. Well, okay. 4 edges with 4 symbols. Okay. Let's do it.
I think with more symbols on the left as well.
Let's try with 2 symbols, first of all. That's pretty boring. All right, let's try increasing the symbol count on. So that is 2 symbols on the left. And we want to go, let's try going to 3 symbols on the left. We don't know which of these is reporting back, do we? That's what, in principle, that monitoring thing would allow us to see. Because that would allow us to see that counts kernel. Oh, gosh. That would, in principle, allow us to see which kernel is failing to report back here. Okay, so what do we think is happening when this thing is blowing up like this? Do we know? Oh, came back.
No, what's weird is it is not aborting. That bothers me the most.
Oh, look at that guy. That guy is reminiscent of some of the ones that we see with, okay, so there's several interesting ones here. Okay, so let's look at this one first. Hello, why isn't that flashing? There, now it flashed. Okay. Okay, let's go back up here to collect our technology for looking at them. Oh, that's weird. We were looking at a 3. Look, we're looking at 3 initial things there. We don't want to do that. We want to look at 2. Okay. Boring. Let's just try looking at 3 there. I don't think that's going to do anything. Nope. I mean, it may do something. It may count somehow the initial conditions, but I don't think it's doing anything else. So that one is really reminiscent of ones that we've seen in the simpler case. So I'm not that interested in that one. All right, let's try running this again. Maybe we should run it for slightly less than 10 steps. Well, I like to see 10 steps. And if the interrupter is working correctly, it shouldn't be a problem. I see. It's not even feeding itself out. Actually, we could figure out what was going on by looking at which kernels are reused here, because it's going to reuse a kernel once that kernel is finished. All right, what do you think? Do you think that guy is interesting? It might be. Guy's a possibility, and I don't think that one's going to be interesting, but let's try this one. Oh dear. Let's hope this doesn't just blow itself up. Let's look at where it got to so far. Oh no, there we go. Ooh, that's a very jolly one. Look at that guy. What the heck is it doing? Let's just check it with two initial hyperedges, self-loop hyperedges. But look at these guys. I mean, those, I bet those are counting in some way. By the way, we can try in the wild, once we have the ordered hypergraph, the different, okay, what do you think of that one? I mean, that one's kind of fun. It's a 2 to 4. Let's look at what the rule looks like. Not very illuminating and not the best visualization. Oh, wow. How can that be? It's disconnect. Well, there must be something
it is
missing on.
disconnected. Oh, wait, no.
Yeah, the 444 hyperedge is disconnected.
No, it's not. There's 234 also.
Oh, yes.
No, it's not disconnected.
Well, then why is it showing as disconnected here?
Well, because it doesn't render it correctly.
Shall I send you this one? I'm going to send you this one.
Can you just do ordered hypergraph plot of the right-hand side?
That looks completely wrong. Well, let's see. Can I do vertex labels?
Yeah.
I can say vertex labels. What is it doing?
Okay, so there are a lot of them missing. So 444 is missing.
Can we get it to do?
13
Yeah.
is missing.
Yeah.
Okay, let's see.
I mean, this basically everything is missing here. Do you want to? I mean, is there a way of getting it to use the other rendering scheme? Now, this is clearly very broken.
Yes, there's hyperedge style goes to colors.
Okay.
But it doesn't work in rule plot.
Okay, but this one it should work in.
Yeah. Yeah, also can you send it to me, because
I just sent it to you. I just sent it to you. HyperEdge style.
Yeah, it's a string.
Does it have a lowercase e?
I think so.
Okay, so 1, 2. 2 goes to 3, 4. That's correct. That's that piece there.
Yeah.
4 has a self-loopy. Yeah, well, so it's wrong. Okay, but anyway, that's so. But this thing, which who knows whether it's how correct that is. I mean, we could presumably just to see whether it is dramatically different. We could put in. Okay, so there's a ton of self loops missing, right?
Yeah.
Although it's not clear that they cause, that they do very much. But let's at least try taking this and let's look at the causal graph from this. Oh my gosh. So we try running the causal graph longer. Okay, what's this doing? Is this an ordinary graph? Can I do graph 3D and things on it?
I think so, yeah. It is a graph.
Well, so what do you conclude from this causal graph for this thing? I don't really know yet how to read causal graphs properly for these things.
I mean, first, I think we need to know where the origin is.
So maybe we should be indicating that more clearly. I think we should.
There actually is not any origin because initial condition is not a vertex here.
Well, how do you know that?
Well, because that's the way it works. It doesn't include vertex for initial condition.
Why not? Oh, because it only has the event.
Because it's not an event.
Yeah, it has the first event, but maybe it should have a negative.
It might have an
infinity.
option for
I
including.
think it should have an option to include.
Yeah.
Yeah, why not? To include the initial and final states. You know, it should channel the S matrix, so to speak, and actually look at the asymptotic initial and final states. I think we should do that. Let's add that to both the to-do list. I think it's time to wrap up for tonight.
I mean, we can find it from the graph itself as well by taking all vertices to 0 in degree.
Yeah, I understand. I'm too tired. Hold on. Let me just make a note of both of these points. So first, we want to document an option here. The option is include, should we say, asymptotic states, initial final states, initial events, include.
No, it's not an event.
What?
It's not an event. I mean, include initial and final states. We might be able to shorten it.
Well, I think we should call it include asymptotic events.
Or maybe they should be separate.
Well, we can have a special thing for initial, comma, final. True, false. So should we do it by default?
No, I don't think it should, as with final state. Because like if it branches, for example, it would connect all the branches, which does make sense. I actually think the best default might be include initial state, but not the final state.
That's what I'm suggesting. Yeah.
Yeah.
Whether to include events for initial and final states.
But actually, I'm not even sure we should do that because, for instance, if the init is disconnected, why would we want the causal graph to be connected?
Well, you're saying if there's a single initial event. You're saying
if there is a single initial event, it will always be there. The question is if the initial state itself should be an event. In which case, the whole causal graph would have a single source. But it also means if, for example, it's disconnected.
No, I understand. I
Some
understand.
kind of
If the initial state is disconnected, it seems odd to consider it as a single initial event. In other words, you know, the
Yeah.
origin of the universe, right? If it's two disconnected pieces, seems like it should be, you know, this seems like it shouldn't be a single origin if there are two disconnected pieces.
Yeah, which is why I didn't include it in the causal graph.
But I think that's a, you know, a weird corner case. If you start it disconnected, it's a weird corner case. Look, I think.
Well, it's not necessarily disconnected. It might just be causally disconnected, but not spatially disconnected.
How could it be causally disconnected? How is it going to do anything if it's causally disconnected?
Well, suppose the rule input doesn't have any 3 edges, but the initial condition 0, 0, 0, 1, 1, 1, 1.
Okay.
Then it's spatially connected but causally disconnected. And
how will the rule ever do anything?
The causal graph.
Wait. How will the rule do anything in that case? The rule.
Well, it could operate on pieces. Oh, wait.
No, I don't think so.
What do you mean? Suppose the rule just takes a single 2 edge as an input.
Yeah.
Then it would operate on both pieces, which would remain connected by the 3 edge. But it would never touch the 3 edge because it doesn't know anything about it.
All right. This requires more thought. But I think if we can put something in, so let's not include them by default, but if you put in code to include them, then we can, in cases where we need to see them, we can include them. And by the way, that also is relevant for the causal graph for, let me make a note here. It's also relevant for the multi-way system causal graph, right? Because we don't have it there either.
Right.
Okay, hold on. Okay, so now multi-way system. Yeah, and I mean that, how are we going to represent? I mean, we'll literally have to call it, I mean, it's a special event, so to speak, in some sense.
Yeah.
So it's not clear what its name should be. I mean, it's probably its names are initial.
Init and, well, init and final, something like that.
Initial event.
And we might have a different shape for it as well.
Yes, we should. I mean, that's actually very similar. CF, the axioms and conclusions in the theorem prover.
Right.
I mean, you know, this is one of the hacks of quantum field theory, is the setting up of the initial and final states. Because, you know, they never really have them. You know, you can't necessarily get an in QCD, for example, right? You get these random massless gluons that are all traveling at the same speed, but can interact with each other forever.
Yeah.
And, I mean, ultimately, that's what, you know, with quark confinement, you kind of know that something bad is happening with the initial and final states, because you can't have non-interact. I mean, you know, the theory is, right, that you can have a sufficiently far from the interaction region, you can consider the asymptotic states to be non-interacting. So you can model them with, you know, plane waves or whatever you want to use. But that really doesn't work in a theory like QCD. Anyway, I'm getting too tired to think about this stuff. So we should wrap up. I'm going to hopefully have a chance to go on doing some of this exploration tomorrow. Yeah, and there's a long to-do list here. So I think that's it for now.